Again, good morning, dear students. Today is 26th of April 2020, and I'm going to give you another lecture in the chapter 3. On the page 85. We are going to talk about quadratic function and something else that we will go to it later. First of all, in the first lecture, we are going to talk about the quadratic function. When we say quadratic functions, we mean that the functions that they are on the form x squared plus bx. Sometimes we say f of x, the function is should be like that, and plus c. For example, if I say f of x is equal to 5x squared minus 2x plus c plus 3. Here a is equal to 5, b is equal to minus 2, and c is equal to 3. So in this form, I'm going to tell you about the graph of this function and the standard form of the quadratic function. We have a standard form of a quadratic function. When we see the standard form of the quadratic function, it means that this form, you should transform this one to that one. And the important things here, you should pay attention to see that we have minus h plus k. So the standard form is like that. F of x should be as a x h squared plus k. We have minus and we have plus here. Don't forget about this point. So the methods that's very important for this transformation from this normal form to the standard form, we will call it by completing square. Okay, I will teach you how to use the complete square. And we have the vertex, means that the maximum point or the minimum point of the quadratic form or of the quadratic function. So we have a vertex which depends on the h and k. That should be minus, the k should be plus, but in the last we say just h and k is our vertex. Okay, so I'm going to first example. I'm going to clarify the first example for you. Example 1, page 87 in your lecture note, with f of x is equal to 2x squared minus 12x plus 23. So the important things here is to recognize or to do to see how you change this one to the standard form. This is in the normal form, so you should transform it by completing square into the standard form. Okay, first of all we should make a to be 1. So if I want to transform this formula, this example, a should be 1. How? The standard form should be on the form of f of x x squared plus bx plus c. So how we change this one to 1? Do not divide it, because you have a f of x here. There is no 0, something like that. You can do it. So we should find or take out the number 2 or find in the common. So I get what? If I took f of x is equal to, if I am going to take 2 as a factor, I will get what? X squared minus 6x. Just I want to do it between these form, the first or the leading and the second in the middle term. Forget about the third one because we put a bracket here, so I can just write down like that. For doing more exercise, try to multiply this one to there. So 2 multiply 2x squared, I get 2x squared. 2 multiply minus 6, I will get minus 12x. So that's why we can do it. But I don't say 2 multiply 23. Why? Because I have a bracket here. So I change this leading term. We recall this one as a leading term into what together, and this number is the leading coefficient. So next, in the next section, the 3.2, we will deal with this one, and they are very important for our graph. So we will change the leading term into 2, 1. How? By taking a factor between x and x squared. Okay, so, and after this one, I say x squared minus 6x, and we have a rule for completing square. This one, I mean f of x is equal. What's the rule for finding or adding, subtracting, completing square or getting the complete square? We say minus plus b over 2 all of them square. And you know b is what? It's the coefficient with the x. B is the coefficient with the x. How? In this example, b is equal to what? We say b is equal to 6 because we are not dealing with this one. We are dealing with that one because we want to change it to the standard form. That's why. So b is equal to what? B is equal to 6 here. So plus minus, come on, and factor over 2 over 2. Where is b? You say b is equal to 6. Maybe you see b is equal to minus 6. It's okay, you are right. But because we have what? We have the square, we will not write the b. So that's why we say just b. And because you have a square. Now I will get what? In the next section, next step, I will get 2, 23. Can you see? X squared minus 6x. We add and subtract. You know, in the mathematics, if you add or subtract the same part or the same objects, you can say is equal to 0, but we don't say to leave it. We say plus 6 over 2 is equal to 3. 3 to power 2, we will get 9. So the same things happen to here, minus 9. Please do not cancel this 9 with that 9, because if you do it like that, you will get the normal form. No, our plan is going to down to get the standard form. That's why. So we say f of x is equal to, look, please in this step carefully, is equal to x squared minus 6x. We will fix this one with our bracket, and we will make minus 9 to be out, and we have 23. And you know, if we took minus out from this bracket, we should what? We should multiply it by 2, because we change it, we make it this 9, the last part of the completing square, to come to out, but we have a multiplication here. So we see what? We say minus 9, okay, but we multiply it by 2. So finally I get what? Be patient, because we will solve another example and you learn. I know the first time you need more time, but in the second and the third time you will deal with this one, and it's easy for you. And I have what? Minus 18 plus 23. So now this one is our completing square, and I will show you how. You know, when I say completing square, means that you should have this formula. So I'll say is equal to x minus, because you have a minus, and square root of here, x square root of here is equal to what? To equal to 3. And x squared and minus plus is equal to, no, 5. Am I right? Yes, plus 5. Minus 18 plus 23, I will get plus 5. So how I change this one to that one? Because if I say first square minus, because the completing square, you know how to open the completing square in the first chapter. So x squared minus 2 first multiply the second, 2x minus 3, so I get minus 6 plus always the second square. So I got what? I got the same previous example. So why we use this one? Because we cannot get this completing square from this example. That's why we change it to something to be on the standard form and getting the completing square. So our f of x is equal to 2x minus 3 squared plus 5. And you know how to sketch this one in the chapter 2, especially 2.2. We deal with that graphs, how to sketch the graph. We know is equal to, because I have a square, you see this is x squared and minus 3, so 0, 1, 2, 3, here's 3, and plus 5 going to up 1, 2, 3, 4, 5. If you don't know how to sketch this example, please try to review the previous videos, and you get this point is what is the h and k, as I told you. Look, a x minus h squared plus k. So where's h? H is 3, as you know. Where's k? K is 5, as also you know. So this point is minimum point, and I got what? I got the graph like that. And you know there's a shape is very important for us, not the exactly the intersection point, something like that. No, we just need the shape. That's about the example 1, and you can find it in your lecture in the page 68 in the here, how to solve it, how to find in the completing square. Here you can see how to add and subtract the same form. Really in your lecture not need more details. Please follow the steps, because the first time you are dealing with something like that, so you need more details. So for the vertex at the minimum point, you get something like that. And you see that if you are talking about the minimum point and maximum point, you know, if our a, this is what? F of x is equal to ax minus h squared plus k. If a is positive, means that a is some numbers is positive, as we have here. 2 is greater than 0, so you get the minimum point. And you can see the shape is like that, so this point is minimum point. That's why we call minimum value. That's it. So in case if a is negative, for example, I will change my example to f of x to another example, minus 5x minus 2 squared plus 2, and you know the shape will be something like that, right? So here's 2 and 2. So this point, because a is negative, I get what? A is negative, minus 5 is less than 0, a is negative. So I will get what? This point at this vertex will be changed. We called as a maximum, a maximum point, you know, because the graph changed. In this point, the vertex will call minimum point, and that point we'll call our vertex as a maximum point. So also this one about the 86. Now I'm going to another example. We'll find this example and I will solve this example. We said depend on the also on the, it's not the standard form, it's a normal form. So I'm going to translate it to the standard form by what? By using completing square. So we will do it again together, and you again and again and again. After the 3-4 example, you'll finally you get the idea about 3.2. So here's your example. Example 2, page 87. Page 87 in your lecture note. Okay, example 2 say that f of x is equal to 5x squared minus 30x plus 49. We will do it together. This time we will change it. A should be 1, so I will take 5 as a common, so I will get what? Plus 49. You know, we are not dealing with that one because we put the bracket here, so we just take a 5 as a factor, so 5x squared 30x, and I get the idea. So 5, as we did before, minus x plus 49. Now we will add. First, do not do it as a negative and positive. No, say add and subtract something square over 2 over 2. And now think about b. Where is b? Because we say plus minus b over, sorry, plus minus b over 2 square. So where's b? Tell me. Here's b. b is the factor, is the coefficient with x, just x, not x squared. So here's b. A is equal to 1, b is equal to minus 6. So I get what? 6 and 6, and finally I'll get what? 5x minus 6x, and 9, 49. Now I'm going to 5x squared. We will remain just the positive part. Do not forget about this one. It's our completing square. So minus 6 plus 9, and I will take minus 9 plus 49. And do not forget about multiplication, because we took it out from the bracket before. We have multiplication 5 here. So finally I'll get 5x minus 3, as we do it before, first square to third, multiply the second square, the second plus a third square, second square, sorry. And I'll get minus 45 plus 49, and the final term will be as a form plus 4. So because here's positive, I will get something like that. So here's our graph. We have what? Minus 3, 1, 2, 3, plus 4, 1, 2, 3, 4. I will get the shape should be like that. And where's the vertex? Where's h and k? H and k vertex. We see the vertex is equal to, because it should be minus 3, and here's should be positive, so we have 3 and 4, which is what? Was minimum point. Why minimum? Because a is greater than 0, or you can directly deal on the shape. According to the shape, you can decide that's a minimum point. Here's the example 2, and I'm going to the example 3 in the same page. And we have what? F of x is equal to minus x squared. Okay. Minus x squared plus x plus 2. Now we are going to solve this part. Again, it's not difficult. The same steps. We will take just minus here. Be careful, because I should change a should be 1. Change a to be 1. A is equal to minus 1. So I will take minus as a factor. So I'll get x squared minus x. You know why? Because minus multiply minus, I will get plus. So negative multiply positive, negative x squared, negative negative, positive x. Now we have plus 2. Always you will take that 2 outside, or the third term outside in the terminal trinomial, we will leave the third part, the third piece. Okay, now I have what? X squared minus x. Now we have a little bit detail here. Where's plus minus? Here's plus something square over 2 minus something square over 2. So where's b? Tell me about b. B is the coefficient with the x coefficient, so is equal to 1. 1. If you say minus 1, I say you are right, because you have a square. I leave it. I neglected these things. Do not forget about negative, because you know, if you forget negative, our shape will maybe like that. You should change it to reverse it to like that. Otherwise, it remains like that. So this minus is very important, because the graph also carry the mark. That's why I say be careful. So finally, I will get minus x minus plus 1 over 4 minus 1 over 4 plus 2. Now again, I have a negative x squared minus x plus 1 over 4. We will remain this one. Why? Because you know these three parts together, this trinomial will be our completing square. That's why we took out the minus 1 over 4 minus 1 over 4. Sorry, not about this minus, plus 2. And don't forget about here, we should multiply like that as we did it before. So I have negative minus 1 also multiplied. So I will get what? Minus x squared minus x plus 1 over 4. Okay. So plus 1 over 4 plus 2. And this part is our complete square. How we will make it? Take the square root of here. Put the second sign. Take the square root of here. Is equal to 1 over 2. And say is square. So check it. First square. 2 multiply the first. Multiply the second. And the second square. Now, and for this one, we should find the common denominator. Here's 1. Common denominator is equal to 4. So 4 by 1, 4 by 2. Okay, that's the we deal with this one as a 3 case for the common denominator. So please review your chapter 1. So I get what finally? X plus 1 over 2 square plus 9 over 4. So how we deal with this one? 9 over 4 is equal to 2 and 1 quarter. 2 and quarter. So I will get what? Here's x squared. Okay. Because you have a minus 1, means that if it's 1, here's a 1 over 2. So I have what? I have x minus 1 over 2 squared. And because I have the minus, I will get what? I will get something like that. It's equal to minus x 1 over 2 squared. And finally, we have a plus 9 over 4. So I'll get what? Here's, see, here's my 1 over 2. So plus 9 over 2, 1, 2, and a quarter. So it's a 2, 1. Here's 9 over 4. So finally, we get something like that. A point, 1 over 2. And here's 9 over 2. So the vertex what is what? Is 1 over 2 and 9 over 4. That's it. I hope you find these examples are easier for you, and please try to solve 27 and 25. You'll be more experienced with that graph and question. Here's your vertex. Our vertex is what? Our vertex is, the type of vertex is what? Is maximum, you know, and this one is minimum. That's it. That's all about 3.1, and it remains a little bit sketch the graphs. A, B, find the maximum value. You already find it. You can do it all this one in the graph. Now, here's another things. They are in the page 88. It's not a interesting things really, but here it's 21, I think. page 21 in my lecture on the video. So here we have what? We have find the maximum and minimum. As a rule, you can find it directly if you have what? If you have a function like that, you can directly say x is equal to minus b and y is equal to f of this one. So because if I have a question, if I have a direct question and I want to find the maximum and minimum, so how we deal with this one? We can say directly using x is equal to minus b over 2a. What do you mean by that? For example, I say just find the maximum or minimum point directly from this one without using the completing square. Just I say find without sketching. I say find the find the maximum and minimum point. So you can find it by this one and f of x. So I mean x, I mean by f of minus b to a. That's it. So this is y, and I get x and y here. I will get max or min. You know, if here is positive is max and here's negative, I'll get minimum here and I'll get maximum here. As he said, if a is greater than 0, you will get minimum, and if a is less than 0, you will get what? Maximum. Okay, so I have what? F of x in the example 4, page 88 in your lecture note. You have example number 4, say f of x is equal to x squared plus. If you have a function like that, tell me quickly, directly, without using anything, without graphing, just tell me about the maximum and minimum. So I say x is equal to, or h is equal to a. Here's a is equal to what? A is equal to 1 and b is equal to 4. So I say a is equal to minus 4 minus b 2 multiply a. It's equal to 4 over 2 and equal to minus 2. So x is equal to what? X is equal to minus 2. Now, how about f of x or f of minus 2? I will get what? I see f means that put it in the original function. Here I have what? I have x squared plus 4x, means that minus 2 squared plus 4 multiply minus 2, and I get 4 plus minus 8, which is equal to minus 4. Now it's y, so x is equal to minus 2 and y is equal to minus 4. So I'll get what? Minus 2 minus 4. This is my vertex. So tell me, the vertex is max or min? I don't know. I'll depend on the a. A is what? A is less than 1, 0, or a is greater than 0. If a is greater than 0, I'll get minimum. So here's is 1. A is 1. So that's why I get minimum point. Say minimum, because the shape will be like that after doing the example, as you see. So the important thing is here what? Is finding the value minus 2 and minus 4. How about the maximum point? The same. In this example, a is equal to minus 2, b is equal to 4. Now I put minus 4 over 2a is equal to 1. So x is equal to 1 and y is equal to what? F of a. I'll put here, I get minus 3. So here's the point, minus 1 and minus 3. Now a is what? A is minus 2, so means that less than, so I will get maximum. As you, after sketching or completing square, you get this point. It's okay, just for this, really this section is for more assuring that your points are good or not. I'll finish, or our section is finished here. Hope you to try to solve the exercise, especially those one that mention it in your lecture. And try to solve most of them. Okay, thank you for watching the video. Have a nice time.